Hey everyone, welcome back. Today's day two of my 30-day FAANG grind, and I'm trying to solve 6 to 10 lead code problems daily, breaking each down on video, and I'll be sharing my journey and preparation with all of you. I'm Divya. I interned at Massachusetts Institute of Technology, where my area of focus was in statistics and machine learning. Currently, I rank in the top 0.2% globally on LeetCode, and like most of you, I'm preparing for FAANG interviews. Yesterday, we crushed some sliding window basics, and today we are diving into two-pointer techniques, which is absolutely critical for FAANG interviews. We will also make sliding window problems, and we'll keep flexing those pattern muscles. If you find this video helpful, drop a like, share with your friend who is grinding too, and let them or ask them to subscribe so we can crack these interviews together. Let us go. So for today, this is problem number two, which is 167 on lead code, and it is two sum two where input array is sorted. The description is like we have been given an input array called as nums, where it is sorted in ascending order, and we have been given a target, and our objective is to find two different numbers such that when added, they will sum up to target. Okay, let us go back to the dashboard and we'll try to investigate and solve this problem. But before I go there, let me just show you the constraint, which means we cannot apply brute force here. Let us go. So the objective is to find two different numbers such that they sum up to target. And we have been given that the array is already sorted in non-decreasing order, which means it is sorted in increasing order, in ascending order. Okay. How can we solve it using brute force? See, we just have to find two different numbers, right? X and Y. So using brute force, why not we just generate all those pairs, X and Y, and see which of those sum to target, correct? But that will take me order of quadratic path, which is something we don't want to take, correct? Because of time constraint. So in this case, we will be trying to solve this using sliding window. Not exactly sliding window, we'll be solving it using two-pointer technique, okay? Which is kind of similar to sliding window, right? So in this case, our entire window will be of this length, where first pointer left is at the first part and right is at the end. And every time our objective will be to shrink this window until we arrive at the result, okay? And you will see what that means. Just give me a second. Okay, so currently I'm at left is at 2, right is at 15. What do? We add both of them. What do we get? We get 17, right? So we ask ourselves, hey, the current sum that we get is 17. Is it greater, equal, or less than target? It is greater than target, right? So in that case, what do? We know that since it is 17 and it is greater than target, so most of the component of 17 must be coming from that part of the pointer which is higher in magnitude. Which part of the pointer is higher in magnitude? The R part, right? Because it is the greater part. So what do? We shift R to the left. Now, in that case, what will happen again? We get 13, correct? We ask again, is it greater, lesser, or equal to? It is still greater, right? So we subtract, not just subtract, we just move the right part one to the left, okay? We come over here. We again add this two part, left and right. What do we get? We get 9. And since we got 9 and 9 is equivalent to 9, we know that these two components are the one that we're looking for, and it will yield us our answer, right? So what is the time complexity in this case? The time complexity should be order of n. Actually, yeah, we can tell it is pretty much bounded within order of n. And since we are not occupying any other space apart from just storing two different pointers, so the space complexity will be constant, okay? And the time complexity will be order of n. Also, the problem asks us that the index is offsetted by 1, okay? So every time we just have to return the index, we will offset or increment that index by 1 and return the index, which will be the actual answer. So what do I do in the code? The first part is I declare left pointer as the starting part of the array, and the right pointer will point to the end of the array. And I maintain a loop. Left is less than right. Notice here, I have not placed left is equivalent to right or not, right? Why is that the case? If left and right, if both become equal, right? So in that case, what will happen? In that case, we will just create a single element, and we cannot use a single element more than one time, okay? So this is not allowed. So in that case, we will not have an equivalent sign over here. We will ask ourselves like these two values, and we'll store that in the value variable, and we'll just perform the basic operations. If it is equivalent target, we will return the index by incrementing it by 1, and if value is greater than target, we notice that we have to decrement the higher magnitude component, right? So that will be reduced by right minus one, right pointer. It will shrink to the left. If the component is smaller, so in that case, my objective will be to move the left pointer to the right, because our current number, it is still deficit by some magnitude, right? So when we move left to the right, we are moving to a number of higher magnitude, which will fulfill or replace this deficit. And once I am out of this loop, I will simply return left plus one or right plus one, because the problem states that it is guaranteed we will have a solution, and our loop will break when the number will be adjacent to each other, right? So in that case, we can simply return this thing. So yeah, the time complexity is order of n, which is coming from this part here, and space complexity is order of one, which is just this two part, right? Let us go back to the LeetCode dashboard and we'll try to submit this problem and see how it goes. So I've already copied my solution. I will just simply paste it. Let me paste it. And as you can see, all those test cases has been accepted and it is running pretty fine. So yeah, this problem was pretty interesting. It was our first problem of the day, to be honest, which gave us a hands-on or an introduction to two-pointer and how it is moving, right? I hope you understood everything. If you have any questions, please drop them in the comments. I will address them. Until then, see you.